Welcome back to Nature of Code in Rust and GGEZ. In this episode, we're going over example 1.7, which is motion 1.1 using a velocity, but also this is the part of the book that's beginning to get into object-oriented programming. So in processing, Dan Shiffman creates a mover class and then has a bunch of methods on that for moving, the constructor and updating. So we're going to do the same thing, but in Rust. Now in Rust, it's often said that Rust is not an object-oriented language because there are no classes. Well, that's true on maybe like a very technical sense. It's still possible to create class-like structures and use it as if it was an object-oriented language. The only thing that's really missing is going to be inheritance. And there's sort of ways to get around that, but also not ways to get around it. We'll cover those once we get into the inheritance sections of the book later. Until then, let's go ahead and get started. I've already copied over the template, and we're going to go ahead and create ourselves the mover class. Now, I don't have necessarily a folder to put this into, so I'm just going to create the mover right up here in the root here. So we're going to call this mover.rs. And in our main library, we're going to create a mod mover. And that's going to allow us to start writing our code inside of here. Okay, so we want a pub struct mover. And inside, we're going, like the only things we really need to know is, let's see. We need to know our location and our velocity. So our location is a vector2 with an F32, and our velocity is a vector2 with an F32 inside. And we're probably going to want to create a mesh so we can actually store the mesh inside of here too. So you're going to be a mesh. And then I don't think we need necessarily anything else for this. All right, so let's implement for the mover. We're going to create our constructor. Now, Rust doesn't have constructor functions by default. We have to sort of create those ourselves. I'm going to use something called the build, just like a new. So pub function new as our constructor. We don't take in self. For this one, it's just going to be mover : new. So think of it sort of like a static method on the class, so to say. We know we're going to want to take in the locations. Let's actually just take in x, which is an F32, and y, which is an F32. And we're going to return a mover. Now in Rust, we can just say, hey, we're returning a mover. We can also say self with a capital S and knows that this is a mover because we're implementing mover here. Okay, and so then we can just return self and start adding in whatever we need to. So we have a location. That's going to be a vector2 new with x and y. For a velocity, we want this to just be zeroed out. We want to start with 0 velocity. So now is that true? Looking through this, it looks like actually we're going to give it a random velocity between -2 and 2. And that's according to the book. So I actually want to maybe create our velocity up here. Equals, we want a vector2 new. For our x, let's go ahead and use random. That'll give us a random F32, and we'll do another random. Now that gives us a number between 0 and 1. So I would need to like potentially subtract this by 0.5 and then scale it up. It doesn't seem exactly right. So I'm actually going to use something else that we can get from rand, which is a generate range, which is similar to what we have with processing in the random, where we can give it a range of like -2 to +2. So the way this works is we're going to create a mutable RNG, so random number generator equals thread range. Whenever I'm running these, it's actually pulling in what I need out of rand. And then we can just use rng.genRange here. So we're going to say rng.genRange. And then we have to give it a range. So let's do -2.0 ... 2.0. Okay, so that's going to give us a random velocity, and then we can just store the velocity in self. Now we also have to have a mesh. Well, if we want to create a mesh, we also are going to need a context here. So let's go ahead and create our context. We're going to use a mesh builder. New. Let's create a circle for this. Mode, let's just fill in the circle. So that's going to be a draw mode. Our point, where is this going to be? I'm actually going to set this to be a 0.0 location. Radius, how big do we want this to be? Let's make this 25.0. Nice, like big enough to easily see. Tolerance 0 to 1 to make it a true circle, and color. Let's make this white. Then we're going to build it, pass it in the context, and there we go. We now have a mesh created for us. If we're doing this question mark here, we have to actually return a result here. So right now, the question mark is a build returns a game result. So the error actually does return an error. So this could be a result, like just a normal result with the self inside if it's successful, and the error could be a game error. Then we have to say that this is going to be an OK self and return an OK here. That's going to make it a little bit happier, and then we have to actually add this mesh in as well. All right, so then this becomes happy. We can now create our mover. So let's go ahead and do that. Back in the main library, we want to store away our mover. So we're going to have a mover, and you're going to be a type mover, which means we need to actually create that. We have this context here. So that our mover is going to be a mover new. And then we have to give it like a location of wherever we want this to be. I don't know if we really care. We can start in now they start in like a random location. We can easily do that here as well. We can create that RNG again. So let mute RNG equals RNG, and then we'll be able to do that gen range once again here. So the X position is going to be rng.genRange. Let's make it between 0.0 all the way to, well, we need the width. So actually before this, we also need width, height, drawable size. And now we can say we want between 0 and width. And then for the height, we want RNG gen range between 0.0 and height. Now that gives us this result with a game error inside. We're returning a game result here. So I can just question mark this, and we have our mover inside. So we can now store that mover away. Now, what are you upset about? We have a new, we also need to pass in the context. Okay, so We now have stored our mover away. The next thing we need to do is make sure that we're updating the location of the mover. And maybe before we do that, let's make sure we get a draw in so we can actually see it on the screen. This is a lot of code we're writing without checking to see if things are working or not. So let's go ahead and get a draw method added into our mover. So I can implement that here. In the book, this method is called display. So it needs to be public so we can access it outside of here. So public function display. We need to take in a reference to self. We're not going to mutate anything here. We also need a context so that we can, actually call the methods to draw out. They always take context. And we're going to turn we can return a result, or we can just return a game result. It doesn't really matter. And inside of here, so we just need to do a graphics draw, pass it in the context. The drawable is a reference to self.mesh. You might think that I don't need this reference here because we're already having a reference here. In Rust, whenever we use a dot to go inside of something, it does a dereference automatically. So that would be attempting to dereference out of self, get the actual mesh itself, and take ownership of it. We don't want that. We need a reference to it. So that's why we need to tell it we want a reference to this mesh inside of self. And then we need our draw params. So draw param, we want the default draw params, but then we want to update its destination. And to here, we're going to say self.location to array. And then we can just, we don't need the question mark. Here we can just return what this is because graphics draw returns a game result by default. So here's this display. Let's go and call that between clear and present. So self.mover, please, dot display. And we do need a question mark here because it's not the end. It's not the end. We still have a present. Now we do have some warnings here. We're not using this random, so we can get rid of that. And velocity we're not using yet, but we will. So let's go ahead and run this and make sure everything is running as we expect it to. There it is. And so every time we run this, it's going to be in a different location. All right, next up. We're going to want to actually have it move every single update method. So that's going to be an update method here. So pub function update. This needs to be a mutable self, so we can mutate ourselves. And we don't really need anything else in here. In fact, we don't even need to return anything. This is going to just take our velocity and add it to the location. So self.location plus equals self.velocity. And that's it. That's all we need to do. Then we're going to go back into the main library. And in our update method, we're going to call that so self.mover.update. Now, if we run this, we should see our circle move across the screen nice and slowly. However, it's going to just move off the page and just be there, just be gone forever. And so that's when we have the check edges. So if we come back to our mover, we're going to add in a check edges function. Same thing, it's a mutable self. We don't need, we actually do need to take in a context so we can, check the edges of the screen. We need to know what the size of the screen is in order for us to check the edges. We don't need to return anything, however, because getting the width and the height of the entire screen isn't actually going to return any kind of error. So let's actually call this screen width, screen height equals graphics drawable size, pass it in that context, and now we can use this to determine if we need to reset our location here. All right, so if self dot location dot, we can do the x's first. So if location dot x is less than 0, that means we're off the left-hand side of the screen. Let's go ahead and set it to be equal to the right-hand side. So self.location.x is equal, equal to the screen width. Now, otherwise, if self.location.x, if that's greater than screen width, we're going to set our self.location.x is equal to 0.0. All right, and then we're going to do the same thing for the y's. So if self.location.y is less than 0.0, location.y is equal to screen height. And if you're greater than screen height, then set yourself to be 0.0. All right, so now we can call check edges from the main library. Now we could also call check edges from update. If we wanted to do that, we could just, inside of update here, call self.checkEdges. However, we need the context here passed in, so we'd have to pass it in here as well. It's not really a problem. Now the book has us calling up check edges separately inside of the main library here. So let's go ahead and do that. We're going to tell it to update, and then we're going to say we need this context. So self.mover.checkEdges, pass it in that context, and we're good to go. Let's go ahead and update and run again. And now we see our ball moving around the screen, and it's wrapping around successfully too. And I believe that is example 1.7, Motion 101, using velocity added to location to get a basic movement across the screen. Thank you so much for watching, and I'll see you in the next video. Bye.